Welcome back into our OSPF configuration lab. We've gotten OSPF working between the core and the west routers here. We're going to configure OSPF between core and east, and we'll do it a little differently on the east router than we did on the west, just to show you the power of using that wildcard mask. But first off, let's get OSPF working on this serial link between core and east. So we'll set it up on this 192.168.1.4/30 network. So go to here to east, do config T, do router OSPF 10. We will do network 192.168.1.4, 0.0.0.3, because again it's a /30 subnet mask. Put it in area 0. After just a moment, we should have an OSPF neighbor adjacency, and there it is. So now if we go out to the east router, we do show IP route, we actually should learn about those 172.16 networks from the west router eventually, once I give it a little bit of time, and there they are. From the west router, it's learning it via 192.168.1.5, which is the core router, because this is where this router's routes come from. However, since we have not advertised our 172.26 networks from the east, if we go back to core, we do show IP route up here, we do not learn about the 172.26 networks. So let's rectify that. Now you'll recall on the west router, we entered 3 different network commands, one for each of those networks. And again, that works well if we only have 3 or 4 networks. What if we had 100 interfaces on this router and 100 different IP networks? Would you really want to sit and write down 100 network lines in OSPF? Not really. So we can use wildcard masks to refer to entire ranges of networks, even if they may not actually exist on our router. And essentially what happens is OSPF picks the networks that fit the criteria and leaves off the networks that do not fit the criteria. In this case, let's go back and configure OSPF for the entire 172.26.0.0/16 network. So in this case, we'll do router OSPF 10. We'll do network 172.26.0.0, 0.0.255.255, because again, the wildcard mask is the inverse of the subnet mask. We'll put those all in area 0. And now we should be advertising all 3 of these 172.26 networks over to the core and over to the west router. So let's go back up to the core and rerun show IP route. And like magic, we're learning about all 3 of these 172.26 networks because that's what we specified in the wildcard mask for our network line. So now you've seen the 3 basic ways of configuring networks in the OSPF configuration. The first way we did on the core router, which is to say everything on this router gets put in OSPF. I don't care who you are or what you are, you're going to speak OSPF across your interface. On the west router, we individually specified each interface IP address. And on the east router, we specified an entire range of interfaces by using the wildcard mask. Now I'm sure you don't want to watch me set up OSPF on sales, internet, and development, so we'll just kind of fast forward until the point where that's all complete, and we'll pick up our lab there. So now that that's all complete, I actually kind of cheated on these 3 routers and used the every interface is an area 0 command that we did on the core. Let's look at our IP routing table now. So if we go over to development and do show IP route, we have routes all over the place to 172.16, 172.26, 10.11, 10.10. We also have the connected routes to the 10.12, which is the network we happen to be on over here. And life is happy and grand. However, you'll recall when we discussed neighbor selection in OSPF that since all of these routers are on the same segment, they don't all pair with one another. And I set this particular segment up just for the purpose of demonstrating the designated router and backup designated router functionality in OSPF. So let's go over to the core. We'll do show IP OSPF neighbor. Now you'll notice that the 2 routers that are across these serial links, they are in the full state because again, this is a point-to-point link. There's only ever 2 hosts on that point-to-point link. However, on this fast Ethernet link over here, we are neighbors with 10.10.3.1 as the backup designated router, 10.11.3.1 as DR other, and 10.12.3.1 as DR other. And again, if you'll recall, it's really the DR and the BDR that process the routes in OSPF and broadcast them out to everyone else. The neighbor relationship is still there. It's just not exchanging routes with them directly unless it happens to be the DR or the BDR. Now again, let's go to one of these other routers, the 10.11 or the 10.12. 10.11 or 10.12 is Internet and Development. So let's go to Development again. If we do Show IP OSPF Neighbor on this guy, we see what appears to be a different neighbor relationship. We have 10.10.3.1, which is the sales router. It is in a full BDR. 192.168.1.5, which happens to be our core router, it is a DR, and you'll notice that 10.11.3.1, it says two-way DR other. The two-way DR other state basically means I see you over there. I know that I can talk with you. We are technically neighbors, but I'm not exchanging routes with you directly because we're on a shared access link and you are not the DR or the BDR. And again, we won't get too far into DRs and BDRs here at the ICND1 level, but I did want to demonstrate that functionality in the lab. And of course, if you're playing along at home, you can experiment with all of this to your heart's content. But for the time being at least, that concludes our lab on implementing OSPF.